I don't know, 2 times 6. What's that going to be? Super easy, just starting us out. 2 times 6, what do we get? Awesome, we're just getting 12, right? We do 2 times 6, that's like saying 6 plus 6, right? We just did it twice. Because this is just 12. And division is just the backwards version of this, okay? Division is just saying, okay, let's say I had 12 things. Oh, there we go. That was 12. Let's say I had 12 things, and I wanted to, I'm going to rewrite this. We'll do 12 divided by 6. Right? We're saying I want, sorry, lighting's kind of hard to get right with this shiny board. All I'm saying is I'm taking these 12 and I am splitting them up. Give. I'm splitting it up into 6 groups. I'm taking those 12 and I want 6 groups of them, right? Like I have 6 people and I've got 12 pieces of candy. How much is everyone getting? I am making 6 groups. So, let's see. A way I could do this is I just kind of start passing them out, right? If you had 12 pieces and you were just kind of passing them out to everyone, that's probably how you'd go about it, right? You'd start divvying them up. Division is just divvying things up, passing it out to everyone. So I could be like, okay, person 1 gets 1, person 2 gets 1, person 3, you get 1, person 4 gets 1, person 5 gets 1, person 6 gets 1. You get a candy, you get a candy, you get a candy, everyone gets a candy. It's like Oprah when you do division. That was a bad metaphor. Okay, I still have candy left over, so let's keep passing it out. I go back to person 1. I go back to person 2. I go back to person 3. I go back to person 4. I go back to person 5. I go back to person 6. Okay, cool, I've split it all up. Now let's see how much everybody has. Right? Yeah, everybody has 2. I've just divvied it up. I've just split that situation up. Division is just passing out things to everyone and making sure that everyone gets the same amount. That's all. That's all division ever is you're just splitting things up. I'm missing an I in division. You're right. Thank you. I can't spell. Nailed it. See, we all make mistakes. We're all not great at everything, and that's okay. All right. So let's try splitting up something else. We're just splitting things up. We're just passing everything else out. And the person who's like, is this for 4-year-olds? Honey, did we miss the first part? We start at the bottom and we build concepts up. Because if you don't understand the basics, it doesn't matter if you can do the tough stuff because you don't understand what you're doing. So let's just keep going, okay? Because trust me, I have met some people who have their BAs in mathematics who have no idea what they're doing. But don't worry, they can crunch the numbers. Doesn't mean anything, though, if they don't know what it means. All right, let's take the same thing. Let's take 12, and we're going to divide it by 4. Right? You might already know it. Again, it's just that idea of I'm passing everything out. I'm taking what I have, the first number, oh, I did times. Look at where my brain's at. The idea is that you always take the first number and this is what you have. The second number is always basically like the amount of groups you want to make or how many people you're divvying the thing up to. So I'm going to say the groups you're making. Or no, I'll say that differently. I'll say like how much. No, it's the groups. There's 4 people. That's your group. And then this is what you get. So the idea is always you start with the first thing is how much you have, how many groups you're trying to make with that thing, and then how much everybody gets in that group. All right? Yep, everyone's just like, it's 3, it's 3. We know it's 3, we know it's 3. You guys are great. You're great. Thank you for hanging in there while I go over this basic concept, okay? So yeah, if we divvied it up, we'd get 1 person, 2 person, 3 person, 4 person, and then we'd go back. 1 person, 2 person, 3 person, 4 person, and back. 1 person, 2 person, 3 person, 4 person. There's our 4 groups. And within that, everybody gets 3. Awesome. All right. So now we're not going to really do too many problems with that, right? Because I think we get that, right? That was just kind of basically explaining those basic idea of what division is. So let's start making it a little weirder, right? Is everyone good to move on? Great. Let's make it a little weirder. And we're just going to keep that idea of division is just splitting everything up into groups. We're just passing out the candy. I always like to explain it in something I like. So it's like, it's candy. Or I actually had a math class in college where I just rewrote all of my problems to be about kittens because it made it easier for me to think about. Because I enjoyed the idea of passing out kittens to people. So, I mean, do what you need to do to make it work for you, right? That professor was not happy because when everyone else found out I was making my problems about kittens, they started making theirs about weird things, and he was trying to read our proofs, and he's like, you guys, someone wrote about Santa distributing presents. What are we doing here? And I was like, I had a bad effect on everyone. I made it more fun. All right, I want to briefly talk about the idea of fractions, okay? Because I also got a lot of people going, what's a fraction? Fraction, 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 what? So we're going to briefly talk about fractions, because fractions are just secret division. Whenever you see this sign, right, it's just division. That's all it is. And I think when we miss that, we really don't quite get what we're looking at when we look at a fraction. So we're going to take a moment to talk about fractions. Your fear, I know everyone's like, don't say fraction in math class. Don't say the F word in math class. Fraction. So we're going to take a moment to talk about those briefly, okay? So let's just start with some basics of what I'm saying. If I say I have 1/2, I always like to picture a pizza because I like pizza. And when I think about something I like, I feel less afraid of the thing. So I'm going to think about a whole pizza. And if I said I had half a pizza, that would mean that my pizza was cut into 2 slices, and I have one of them. I have divided this line, I have divided this pizza into 2 slices, and I have one of them. That's all a fraction is. You've taken a thing and you've divided it into so many things, and the top is just what you have. Pizza party. Yeah, let's do it. So another one. 2/3. What does that mean? That means I have a whole thing, but I've divided it, right? I've divided it into 3. I've divided it into 3 slices. Burp, burp, burp. And the top is just how much I have. That's all. Bada, 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 bada. Division. I've got 2/3. I have 3 slices. I divide it into 3 parts, and I have 2 of them. I don't know. Let's go with... Let's go with 3/6. Again, the bottom is how much I'm dividing. I'm dividing by 6. Sound effects help everything. Always make sound effects. And some people are like, it's a half! And let's take a look inside a book reading rainbow. So I've got 3 of them. 1, 2, 3. It totally is. That's the same as 1/2. Crazy. So that is what a fraction is. On the very basics, on the very lowest level, a fraction is just saying we are dividing. We are dividing by the bottom number. Okay? Okay. Let's practice this out a few times with dividing some numbers, okay? So I'm going to write some things out with some different ways of writing division, and we're going to practice them out, okay? And remember, a fraction is only saying, whenever you see that line, it's saying that's what we're cutting it up into. That's what we're dividing by. Because division is just cutting things up. It's passing things out. It's making smaller groups. Okay? I like when people are like, this is soothing. I'm like, that's so nice. I'm glad math can be soothing. Also, that was rude. Don't be rude. But for the most part, I love how sweet everyone is. You guys are great. Can we use a calculator? That's a great question. I want for this first part to push you to not use a calculator and instead maybe draw some pictures on your piece of paper. But if you need to use a calculator, that's also okay, because a calculator is just a tool for us. The only reason why I'm pushing away and saying try without, try to use a picture, try to use something else, is because I'm driving home more the concept of what division is than if you can just punch it in. You know what I mean? So it's not really that I'm getting at division facts. It's more that I'm getting at how we think about division. If that vibes with you. But always, if you need that calculator, that tool, use it. There's no shame in it. Okay? Cool. Let's do it. We're just gonna do some basic division problems just to drive home that concept. If you need to draw out the circles, draw out the circles. If you need to draw out little pieces and then number them off, do it. We're just working on cementing in our brains what division is. That's all. We're just cementing that concept in our brains. So even if this seems really easy, that's all I'm asking you to do is just cement that concept. Erase. Because it's really easy as we go forward in mathematics to forget what it means. And I will say right now I'm guilty of that. That I am talking from experience. All right, just some basic, and I'll try and keep these simpler so that we're really just working on that concept of breaking things up right. So that hopefully you don't need a calculator, but again, no shame, you do you, boo. All right, let's do, and I'm just gonna write these out in different ways. I'll do one more. All right, my dears, give these a try. Draw a picture if you need to. These are just division in different forms, and I just want you getting comfy with the idea of what we're doing here. That all division is splitting things up. And then after this, we'll get into some long division, okay? Oh, I'm seeing beautiful answers. You guys are so good at this. You guys are so good at this. Nice, nice. Also, I always like to think about the people who are just scrolling along on their For You page, and this pops up, and they're just like, what? What is happening? Why is it happening? That always just makes me laugh. And if you're lost, that's okay. Take a moment, draw yourself a picture. Remember, we're saying I have this many things, and I want to make this many groups. I have 40 of something. I want to pass it out to 4 people. How many would everyone get? I have 10 of something. I want to split it up into 5 groups. How much would everyone get? The first thing is how much you have. The second thing is how many groups you want to make. The last thing, what you get, is how much would be in that group. How much would everyone get? Looking good, my dears. Looking good. All right. Give you guys a moment more to go, and then we're gonna go, okay? Also, I've seen a couple times my head hurts, and I just want you guys to know, think about if you're working out. I'm gonna step in front and just give you guys a bit of a talk. So if you ever are like in math and you're like, my brain hurts, I want you guys to think about this. Your brain is literally like a part of your body, okay? And you're working it out. You are literally growing part of your brain when you learn something. Okay? Your brain is physically changing when you learn something because your brain is made of neurons. And those neurons are now making a connection. They're getting stronger. Okay? Think of like if you're building your muscles at the gym, if you work out, you are literally building muscle and it hurts because you are changing your body. So when you're learning, if you feel bad because your brain hurts, don't. That means your brain is growing, and that's so cool. That is so cool that your brain is literally getting bigger. Isn't that neat? So don't feel bad. Be proud of yourself for that. All right, let's go. I saw beautiful answers. Beautiful, beautiful answers. Let's go. So if I have 40 things and I'm splitting them up into 4 groups, I have 10. If I have 10 of something, right, and I'm splitting it up, I have 10, I'm passing it out to 5 people, everyone's going to get 2. If I have 28 of something, and I'm splitting it up into 7 groups, okay, this is why I said, like, draw out a picture if you don't know it off the top of your head, just because I want you to physically split them up to cement in your brain what we're doing. You would have 4. And that one's always weird to me. That's a weird math fact for me, but it's true. And I always kind of remember it. This is just a weird way I remember that 28 divided by 7 is 4. Is like 7 times 3 is 21. That one, for some reason, is very easy to me. And then I just add 7 on. That's 28. I don't know if that helps you, but that's how I do that. If that meant nothing to you, that's also okay. All right, last one, 24 divided by 8. If I had 24 things and I split them up into 8 groups, 24 pieces of candy, I hand them out to 8 people. How many pieces is everyone getting? Everyone's getting 3. And if you're unsure if you got the right answer, here is always a way to check. Because I like checking things. It makes it easier. So a way to check is to do division backwards. So let's do, what's 3 times 8? If I do 3 times 8, I get 24. Well, gosh dang, that's just because it's the opposite. If I did 4 times 7, I get 28. Because it's just the opposite. If I do 2 times 5, again, we're getting 10 because division's just the opposite. If I did 10 times 4, again, I'm getting that opposite. I'm getting 40. So that's how we know we did it right. Awesome, awesome, awesome. All right, so now we're going to do long division. You guys ready for it? Let's do it. Does anyone need this a moment more? I'm not ready to bring it on. That's the attitude I like. That's the attitude you bring into this. I love that. Yes. Everyone's like, no, but we'll do it. I love it. I love it. That's it. Do it even though you're scared. Yes. Just do the thing. Just do it. Okay, we're going to do long division. And we're going to talk a little bit about what long division is useful for. Because again, when I was learning long division, I'm going to bring this light back. Is that shining on the thing? It shines on the board weird and I don't, it's hard. Lighting's hard, you guys. Oh gosh, oh gosh. Okay, that's a little better. Lighting is hard. Okay, we're going to talk a little bit about what long division is useful for. Because when I was learning long division, I was like, neato, but I have a calculator. I can just use the calculator, right? So even if we don't get into showing you some of the things it's useful for, we'll at least talk about it. Okay, so before we go over it, we're going to talk very briefly about what it is. So long division is something that we call an algorithm. And an algorithm is just a series of steps that we always take to do something, okay? It's kind of like a machine. We're going to put something in, and if we follow these steps, we get the thing out. Okay, so we're just learning a bunch of, my hair's like over my bow tied weird. Okay, sorry about that. We are just following a series of steps to get the thing. Also, we're probably going to be dealing with remainders and decimals and stuff because I am literally just pulling these off the top of my head. I'll try and pull some nice ones off to start with, but then it's going to get weird and we're going to look at the weird ones because I'm just making up numbers, right? We're just going with it. And that's okay. I think that's really good to look at because in real life, things aren't always that nice. Alas. So it's good to see them. All right. Let's do this. Oh, did I just get my hair in my coffee? I don't think so. I think we're good. All right. So I say all right a lot. We're gonna start with our weird little thing here. How cool. I'm just gonna pick something. I'm gonna pick a problem that's just gonna, fall off the bone. That's a really weird metaphor, but I'm thinking about like it's so easy. It's like a pot roast, I'm a vegetarian. I don't know what I'm talking about. It's gonna be an easy example to start with, right? And then we'll get more complicated from there. Take a moment, write this down, and then we're gonna go through it. Like Deku. Oh, you guys are funny. All right, some of you are like, I know the answer, right? But we're just kind of gonna go through the algorithm because I think it's really nice when you can just see the answer to then see how the algorithm works out, So let's do it. So here's the long division algorithm. We're going to walk through it several times before I set you out on your own. Honey, there's literally nothing to be confused about right now. Just write it down because we haven't even started on it. So it's okay. Deep breaths. It's going to be okay. I know sometimes we look at things and panic and it's like, there's nothing to panic about yet. Because we haven't even started. Nothing's been explained, so it's okay to not know. All right. Let's do it. It does look like a square root sign, doesn't it? Which is kind of neat and honestly kind of related. Because think about what we do with square roots if you were here for that. Because square roots is a form of division. We did something there, didn't we? Okay. So, when I do long division, this is what I do. I want to divide this thing by this guy. This is what I want to divide. This is what I want to divide by. So I'm basically saying I want to take 284 and make 2 groups of it. All right? It was like if we wrote this out how we did before, we could have written it out as 284 divided by 2. This is just another way of writing that. Or, and I'll erase this stuff at the top in just a second, or 284 over 2. Those are saying the same exact thing as this guy. Long division is just another way of writing out the division. Okay? It's just another form. It's just another form. Gonna erase those and we're gonna go at it. And that's why some of you are like, well, I already know it. I can see what it is. That's awesome. You guys are so smart. Y'all are so wonderful. And you all are so capable of this, even if you don't believe it yet. All right, so we're gonna start and go, okay, how many times does 2 go into 2? We are ignoring this part of the equation, okay? We are just looking at these first 2. We're always going to start with this guy and then look at the first one. So how many times does 2 go into 2? We are literally just not looking at this. This doesn't exist at the moment. How many times does 2 go into 2? Awesome, once. That's it. Long division is really just trying to break a big problem into many small problems. And that's a lot of what we do in higher up math, okay? It's not necessarily that the math is harder, it's just that you're doing more of it. We take a big problem and we cut it up into manageable bite-sized pieces. That's what we do in mathematics, and that's what we're doing today. So you guys are awesome. 2 goes into 2 once. It fits in 1 time. All right. So now we would go, what's 1 times 2? We go, what's 1 times 2? And this might not make sense on why we're doing this right now, but when I show you a different problem, it'll make more sense. 1 times 2 is going to be 2. And we write that right below it. And for this first one, I would just kind of let it wash over you. Write down it, let it wash over you, okay? Now I'm going to subtract. 2 minus 2 is 0. So on the side, I'm going to write down what we've done so far. So at first, we divided, right? 2 goes into 2. How many times? Then we multiplied. 1 times 2 is 2. Then we subtracted. All right, and now the next step, the next and final part of this algorithm, before we repeat it all, is we bring it down. We are going to now bring down the next number. Because again, our goal is just to make this bite size and manageable. So now, instead of focusing on this big number, we're just going to focus on 8. Our last step was bring it down. And again, if this is weird and scary right now, if you don't get what we're doing, it's okay. We're just going to do it many times and get used to it. It's okay to be confused right now. Just let this wash over you, and we're going to keep doing it, okay? Until it becomes more comfortable. It's like dribbling a ball. When you first started doing that, it was hard and confusing and you couldn't do it right. But then you practiced it and it became easier. And that's what we're doing. So I'm going to mark this off. This was our algorithm. We divided. 2 divided by 2 got us 1. We multiplied. 1 times 2 got us 2. We subtracted. 2 minus 2 gave us 0. And then we brought the next number down. That is the algorithm. That is the process. So now we start from the top. We divide. And again, we're working on that small bite-sized piece. So we're just looking at 8. We are just looking at 8. How many times does 2 go into 8? We're dividing. How many times does 2 go into 8? How many times does 2 go into 8? Beautiful. I'm starting to see some answers. Beautiful, beautiful. How many times does 2 go into 8? Awesome, you guys, it goes in 4 times. So I write that up here. And now I go, okay, 4 times 2, we're on the multiply stage, gives me 8. And now I subtract. 8 minus 8 gives me 0 again. All right, now we bring down the next number. Now we're here, we're gonna bring down the next number. I bring down 4. So this was just us cutting it up into easy pieces. We did the first one, the second one, now we're doing the last part. Okay, so we go right back up to the top. We divide. How many times does 2 go into 4? How many times does 2 go into 4? Awesome, 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 you guys. It goes in 2 times. 2 times 2 is 4. I multiplied. 2 times 2 gave me 4. And now we subtract. 4 minus 4 gives me 0. And then I would bring down. There's nothing left to bring down. We did it, we're done. 284 divided by 2 is 142. Yes, we will do one with decimals. This was just a first one to bring up the algorithm, okay? But yes, we will, because the next one is going to be harder. No, we did it! Yay! It's okay to be confused right now, because this may have been your first time exposed to the algorithm, and the algorithm takes a little bit of time to get comfortable with. So I wouldn't use the word confused necessarily. I might say it's uncomfortable right now. Right? We're not used to using it. We don't have the pattern down yet. And that's okay, because to get the pattern, it takes practice. So that's what we're going to do. We're going to keep practicing it. And that's okay. All right. Let's do it again. Let's do it again. Let's do it again. We'll do it again. That's okay. It's okay even if it's not your first time and you're like, it's okay to have to see something many times to get used to it. Yeah, and you may have learned this a different way. That's okay. All right. I'm just going to pick some random numbers. We're going to do a harder one, okay? And since I'm going to be picking random numbers, you'll see now why the algorithm is more useful, because it's like, okay, well, we could have just done that, right? I can look at 284 and know how to split it up by 2. Yep, we're going to do it again. We're going to do it again with harder numbers. And I'm just going to pick these numbers randomly, so I don't even know what the answer is going to get. And we're just going to do a couple like that, where I'm just picking random numbers and we're going through and we're just going to see what happens with them. And then I'm going to give you guys some to go over, okay? To try on your own and give it some practice. But don't worry, we're going to be doing these together for a bit. Okay? We're just going to see what weirdness comes up when I pick random numbers. I don't know, let's do 4, 7, 9. 4, 7, 9. We're going to divide that by 3. I have no idea off the top of my head if that's divisible nicely by 3. I don't know if we'll get a remainder or go into the decimals, okay? But we're going to try it and find out, because that's what happens in life. Woo! All right, and remember, some people are coming up and asking me to do different things. But remember, if you have questions that's not on the topic we are doing today, please send me a message with them. We are just going to be focusing on this. Yeah, we're probably going to get a remainder with this. I kind of did that on purpose. I was kind of hoping for a remainder. And it's okay to get a remainder. And it's okay to have to go into the decimals, because most of the time in life, when you do these types of problems, that's what's going to happen. Right, let's do it. Let's do it. All right. Yeah, I didn't want this one to go as nicely, so don't panic. It's not going to be as nice. All right, first thing we do, 3 divided by 4. How many times does 3 go into 4? How many times does 3 go into 4? Some of you guys already have the answer. You're beautiful. Awesome. It goes in 1 time. I can only get 3 out of 4 1 time. That's all the amount of times I can pull 3 out of 4. Once. So I'm going to write 1 up there. And then I move on to multiply. What's 1 times 3? Well, 1 times 3 is 3. And here's why the subtraction part is necessary, okay? Because we're going to do 4 minus 3. 4 minus 3 is 1. Beautiful. Now we're going to bring down the 7. I find the arrow satisfying to write. And our new number we're going to look at is 17. I don't know why, I just find it very satisfying to bring down the number. Bring it down, bring it down, bring it down. Bring down the 7. Awesome. All right. So now we have to think about, yes, I love that we're already guessing. Oh, beautiful. Beautiful. You guys are beautiful. You're already on to the next step and you're guessing. I'm seeing 5s. I'm seeing 4s. I love it. I love it. All right. And I love that, again, I am seeing question marks with stuff, because that means that you're brave enough to guess. And that's beautiful. All right. So we are going to do, how many times does 3 go into 17? So here's a kind of a way to check. I saw 4, so let's check if it's 4. All right, what's 3 times 4? All right, 3 times 4 gives me 12. Now, could I take another 3 out of this? Could I take another 3 out of 12? I mean, could I fit another 3 in there? I could, so it's going to be 5. You know what? Let's just see what it looks like if I tried the wrong number, okay? Let's just see what it would look like. So if I said 4, I was like, I think it's 4. Let's give it a shot. I would do 4 times 3 and get 12. And then I would subtract. And then I subtract this and I'm going to get 5. So here's where I know that I could have taken another one out, right? Because I could take another thing out of 5. So it kind of has that built-in check. Please don't spam the chat. It has that built-in check, okay? People who are spamming with a bunch of faces, I will kick you out, okay? Please don't. It makes it very hard for me to read and check in on people. Thank you. All right. So I've built in that check. Okay, that's fine. You're going... All right. All right. So I've built that in. So now I am going to just erase that part, and no, I could take another one out. I kind of like that it has that built-in check for us. And always, always do your logic checks, okay? So now we're going to do 5. I saw 5 as the other one. So let's do it. Okay, 5 times 3 gives me 15. Now I'm going to subtract. 17 minus 15 gives me 2. I can't take 3 out of 2, so I know I did it right. Sorry, you guys. Give me just a second here. Oh, I have a question. Are there any of my friends in this chat who would like to mod? So anyone that I'm mutuals with is what I should say. Sorry for the delay, my dears. All right, cool. I do find it, honestly, very interesting. When people think that they can spam a teacher. Like I don't deal with you on a daily basis, you know? Okay. I am an actual teacher. And remember, if you're getting kicked out of here, you're getting blocked from my entire account. Okay? And I don't re-add people. Thank you. Thank you to everyone who's being so nice and wonderful and patient. All right, let's keep going, shall we? All right, my dears. So let's see. Where were we? You threw me off my groove. I'm sorry, but you threw off the Emperor's Groove. All right, so we had just figured out that 2 was rewind. We're just going to talk through the entire thing and bring us back to where we were, okay? So we took 3 and we said how many times does that go into 4? It went in once. We multiplied by 3 to get 3. We subtracted and got 1. We brought the next number down. Then we brought it back up. How many times does 3 go into our new number of 17? We discovered that it went in 5 times over some trial and error. I love a good trial and error. So 3 times 5 gave us 15. We subtracted, we got 2, which brings us to the next step. We're gonna bring it down. Bring it down. We get 9. So now the last number is 29. So now let's take a moment and make some guesses at how many times does 3 go into 29? Because maybe you don't know off the top of your head, but let's make some guesses. Let's make some guesses. How many times does 3 go into 29? Awesome, I'm seeing 9, I'm seeing 8, I'm seeing 7. At least 2. That is a fair place to start. You're like, well, it's at least this. And you know what? If you think it's at least something, try it out like we did with the 4 and the 3. That's okay. It's okay to try stuff out. All right. Awesome, awesome, awesome. I love that we're making guesses. I love that I see so many guesses. That's so good. All right. Oh, someone went if 30. Ooh, someone made a good point in the chat and I love it. So let's talk about it. If someone said, you know what, this number's really close to 30, right? And I know that 3 goes into 30 10 times. So this must go in 9 times. Beautiful. Beautiful logic. I love it. That was beautiful. Thank you for that. Beautiful, beautiful, beautiful. So let's try 9. I liked that logic. 9. 9 times 3 is 27. So I got to that times. I'm going to write it down. And now we subtract. And everyone was saying we got a remainder of 2. Beautiful. So now here is something you can do. Okay? There's 2 ways to go about this, and your teacher will tell you what they want you to do. You can say 159 with a remainder of 2. That is an acceptable way to leave your answer most of the time, and your teacher will tell you if that's what they want you to do. But I do teach geometry. Again, if there are any requests, send me a message on them because it's not what we're doing today. All right, but there's another thing you can do. Let's say you're in higher up math. Let's say it's not acceptable to have a remainder of 2. Let's say you need to get a more precise answer. You need a decimal. All right? Let's add a decimal. So what you would do, if your teacher wants you to get to a certain decimal point, is we would extend this. burp, burp, burp. And we'd add a decimal in. And we'd add a 0. Because can we agree, if we ignore everything else, that 479.0 is just the same thing as 479? That's the same thing if I add a 0 at the decimal point. Because that decimal point and that 0 was always there. It was hiding. There are always invisible zeros behind your number the whole time. The whole time. Oh my gosh, they're so sneaky. So very, very sneaky. It's okay. Decimals are tricky. That's why we practice them. It's important to practice the things we're not good at, because if we only practice the things we're good at, well, we're not really getting better then, are we? Decimals are the bane of your existence. Oh no. All right. So here's how we handle the decimal. When we put the decimal in, we are going to bring the decimal straight up in our answer. So then if we put a decimal here, we bring it straight up, put it into your problem already, okay? So we added the decimal in the problem, we take it straight up and add it. All right, so now we are just going to continue the process. All right, we bring the 0 down. And we get 20. 20's our new number. Singing helps. So how many times does 3 go into 20? How many times does 3 go into 20? Awesome. We get 6. Beautiful. And someone brought up a point. We get 6. So I do 6. And now what's 3 times 6? Well, 3 times 6 is 18. So we'll put the 18 down. Then we go to our subtract phase, and we get 2. And then if I added another 0 and brought that down, well, my goodness, we're just back at 20 now, aren't we? And someone brought up that it was just going to be 6, 6, 6, 6, 6, 6, 6, 6, 6, 6, 6, 6, 6, 6 after the decimal point forever and ever. And they're totally right, because if we continued this process, well, we'd get 6 again, and then we'd divide it by 3. We'd get 6 again, and we'd multiply it and get 18, and we'd subtract, and we'd get 20, and then we'd bring another 0 down, and then we'd multiply. And, we just continue this over and over and over, and we'd continue to get 6. So I know I can stop, and I can just write a little dash telling me that the 6 is going to repeat forever. And that would be my final answer in decimal form. Beautiful. It repeating division. Great. All right, my dears, I am going to give you a problem, and I want you to try it, okay? And then we're going to go over it together, okay? It's okay to be lost. Take a moment. Make sure you have this side part written down. This is our algorithm. Have this written down and see what you can get through. Get as far as you can. And remember what we are doing. What we are doing is we're just going through this. How many times does 3 go into 4? Once. 1 times 3 gave us 3. Then we subtract and get 1. And then we bring the next number down to get our new number that we're going to divide by. And we keep going through that process over and over and over. All right, so I'm gonna give you one. It's okay, I have a mod working on it, loves. So you just focus on you. So yep, we've got the mod taking care of it. So if anyone's spamming, don't worry. Just focus on what you need to do, okay? And mod, thank you so much. You're wonderful. Right. It's okay. Oh, I love that. I don't think I can do this, but I will try. That's the attitude. Yes. Try it. See how far you can get. Because remember, even if you do it a little wrong, you did something right. All right, so let's just be brave and try it, and then we'll go over it together. And remember that I believe in you. It's making a weird squeaking noise. I'm easily amused. And I'm going to say it's okay to do either the remainder or continue and get a decimal. I will show you both ways when we go over it, okay? But do follow your bliss on it. Either get me a remainder or a decimal if it fits. I will show you both ways, though. Let's pick a number. I don't know. We're going to go with 5, 7, I don't know, 2. Let's divide it by 4. These are just numbers I picked off the top of my head. Give it a try. I need a drink of water. Remember to hydrate. Yep, don't worry if you're lost. We will go through this again, okay? I like that someone gave me the answer in pieces of candy. I can bring my headphones down. They're kind of hurting my ears. Again, I love all the people who are unsure, but they're still throwing their answer out there. I'm so proud of you. Feel free to use a calculator for the small steps, okay? Try and go through the algorithm, but if you need a calculator for the small steps, do it, okay? I'd say don't let yourself, because right now what we're focused on is the algorithm, right? Beautiful. These are looking so good, my dears. Give people a moment more and we're gonna go through it. Oh, I love seeing you guys get so happy that you got the answer. Yes, it is hard without paper. Oh my, what are you trying to write on? Huh? Oh my gosh, I just got the wonderful image of someone like writing on their arm for this. It'd be like, all right, so. In a paper, so I did it. You guys are so wonderful. I'm so proud of all of you. I'm just so proud of all of you. All right. Let's do it. Let's go over it. Okay? Check your work as we go. And if you are unsure, just follow along with us, okay? That's okay. Let's go. All right. 4 goes into 5 one time. I can pull 4 out of 5 once. Now I'm going to do 1 times 4 and get 4. Then I'm going to subtract. 5 minus 4 is 1. Now I'm going to bring the next number down. 17. How many times, and I go back to the top, how many times does 4 go into 17? Let's see. 4 goes into 17. 12. 4 goes in 4 times. 4 times 4 is 16. Subtract, and I'll get 1. Now I bring the next number down. And I have 12. I accidentally made this a nice answer. Yay, accidental nice answers. Yay. 4 goes into 12 3 times. 3 times 4 is 12. I subtract. I get 0. The next number I'd bring down would be a 0 if I did it, so I know we're done. 143. Great job, everyone. Great job. It's okay that you had it wrong. That just means you got the opportunity to check and learn something new. Remember, we learn a lot from our mistakes. Successes? Not so much. All right, my dears. We are going to do one more. That's okay, but did you see where you messed up? Because that's the important part. Oh, I'm so proud of all of you guys. I'm so proud of all of you. Even the people who got it a little wrong. Even the people who didn't quite get it. I'm proud of you because you tried. I have done square roots, so if you go to my YouTube channel, which is in my link tree, there's a whole lesson on square roots. All right, let's do one more, and then we're going to get off for the day, but I'll briefly tell you about where long division gets used in higher up things. Because right now, long division is really just an algorithm that they're trying to teach you early so that you can apply it to complex math when you have more pieces to play with. Okay? It's very useful for things that we cannot type into calculators. Which is weird because you're going to be like, but when can't I type a division problem into a calculator? Oh, there are times. Math gets crazy, and that's why I love it. All right. We're going to do one more. We'll talk a little bit about where this goes, and then we'll call it a day. I'm just so proud of all of you spending your Saturday with me. All right, let's do it. Oh, you guys are so sweet. All right, let's do... Okay, I know this one's going to get us a remainder or a decimal, okay? So, either do a remainder, or if you're feeling like doing the decimal, do the decimal, okay? Give it a try. As I was out on a mission. Oh, well, you see, now I've got a bad joke. My eraser's right here. Bad jokes. All right, give this guy a try. I'm gonna drink more water. And remember, if you ever miss any part of these, I put them up on my YouTube channel later on in the day. I'm glad some of you liked my bad joke. You can find my YouTube in my link tree. So if you go to my bio and click on my link tree, you will see the link for my YouTube. It'll bring you straight to my YouTube channel. So you just gotta go to my page, go into my bio, click my link tree. Did I accidentally make it almost the same? Because that's kind of funny. Answers rolling in, I love it. You did the decimals, nice. I'm seeing remainders and I'm seeing decimals. Some people did it both ways. Look at you go. Look at you go. Awesome, I'll give people a moment more. And then we'll get started. Thank you for the roses. It's okay. If you're getting upset, take a breath and know that it's okay. At one point, everybody gets upset at math. Everybody does. That's just reality. No matter how good you are at math, you're gonna get upset at it. It's gonna push you to your limits, and that's an okay thing. All right? And if you said, oh, I've never been pushed to my limits in math, well, then maybe you're not pushing yourself hard enough. And I would encourage you to push yourself harder. Because if you're pushing yourself to your limits, you're learning more than someone who's not. And I'm so proud of you for that. All right, let's do this. Let's do it. We can do this. All right. How many times does 5 go into 7? 5 goes into 7 one time. 1. 1 times 5 is 5. We subtract. Whoosha. 7 minus 5 is 2. I'm gonna bring down the 9. Bring it down. Now we're dealing with 29. How many times does 5 go into 29? I can pull 25 out of that, so that's 5 times. All right, 5 times 5 is 25. Sorry, I'm trying to like move my finger with like where it is on here on our algorithm. Now we're gonna subtract. 29 minus 25 is 4. I'm gonna bring down the 8. Bring it down. Everything helps if you sing. All right, how many times does 5 go into 48? I'm thinking I'm gonna be able to pull 45 out. So let's see, 5 times what gives me 45? 9. 5 times 9 gives me 45, so bam. Which is kind of the next question. 9 times 5 is 45. We subtract. Okay, that's 3. I can subtract. Look at me go. Look at me with the basic maths. Heck yeah. All right, so this is where some people said 159 with a remainder of 3. So we write that up here, 159 with a remainder of 3. That is an acceptable answer. And in some places, your teacher might specifically ask for that. But, sometimes you need a decimal. So let's add the decimal and keep going, shall we? Add the decimal, and when I add the decimal, I have to bring it up and add the decimal on top. And we add a 0. Because there's always those imaginary zeros behind your number. They're always there, supporting the number, being there. Good for them. So let's bring that 0 down. And we get 30. All right, so how many times does 5 go into 30? 5 goes into 30 6 times. Whooshaw. So now we've got 5 times 6, which gives me 30. We subtract and get 0. So we're done. The final decimal is 159.6. Nice! And that's why I like adding the decimal and finding out, because sometimes we don't have to go too much further to find the end of it. That's kind of nice. That's kind of nice. Oh, thank you for what, I don't even know what to call that. That was cute though. Yeah, you got it half right. Good for you. Good for you. All right, and I saw someone ask about this doing long division with algebra. So what you're describing is polynomial long division, which is actually one of my absolute favorite things and the reason why we need long division. So I am very tired at the moment, so I need to get off. But that's actually, I love that you bring that up. And I can do something on that more later as like a next steps to this too, okay? But it's basically that same exact process. And that's where this goes. So sometimes, I'm going to erase this and I'm going to show you something really quick, okay? You don't need to write this down. You don't need to be confused by what I'm going to show you, because I'm just going to show you where this goes. Because you could look at me and you could say, you know what, Mike, I could just take 798, plug that in my calculator and divide it by 5. Why did I need to do that process? And I would look at you and I would go, you're absolutely right. You're absolutely right. You could have just used a calculator and you would have gotten there so much faster. But polynomial, that sounds fruity. Oh, that was hilarious. Thank you for that. Oh, I see what you did there. Oh, that's good. That's really good. Where was my train of thought? All right, polynomial long division. But when I start getting algebra into the mix, and there are situations where you do need to divide algebraic statements, okay? And I will show you briefly why. There are many reasons, but I will tell you one of the reasons why it might be nice to divide polynomials. So things with x's and stuff, okay? Which you can't just type in a calculator. So this is just prep. This is just teaching you the algorithm that you would use to do harder math. And some of this math actually has to do really cool stuff, like space travel and projectiles and all of that cool stuff. So that's where this leads to. This leads to things that have helped us with aerospace engineering. That's so neat. That's so neat. But what we did is we broke it down into little processes so that you can start to get a little piece of it before you learn the whole thing. So that when you go to the really big complex thing, you'll go, wait a minute, I've seen that before. And then you'll learn it that much better. So that's why we teach this so early on to people. Is because later on, we want you to recognize it. And I wish we'd tell you that right away, because I was always so frustrated of like, why do I need this? I don't get it if I could just type it in a calculator. But it's just us going somewhere with it. Yeah. And I think that's so cool. I think that's so neat. We can do crazy things with mathematics. Mathematics is just the tool. You are the creative genius behind it who gets to make it into beautiful things. All right. So yeah, let me show you just a little bit of what that looks like. You don't have to write this down, but just like so you can kind of be like, oh, that's the thing you're talking about, okay? So it might look big and complicated, but again, it's just one of those things of like, this is where this is going. Erase. Mathematics is one of those things that we're just constantly building on to make cooler and cooler stuff. I don't know. I'm just throwing this out there, so this might not divide evenly or nicely. If anyone's out there who knows a lot about math. But if it's like, I don't know. I want to see how many times like x plus 1 goes into that situation. This might be an example of polynomial long division, all right? We've got algebra that we want to divide. And what this actually ends up trying to find for us is sometimes it gets used to find where like projectiles might hit the ground. So like where that might be. If I launched, where that might be. So that's the very basics of what it might be looking at. So this is an algorithm that helps you further on. We're not actually going to solve this today, but that's where this is headed. And remember, division is just cutting things up into smaller groups. That's all we're ever doing with division, is just we're divvying something out. It's okay. You're like, this looks scary. Don't worry, you're probably a ways from it, and that's okay. But that's where it's headed. And isn't that neat? Isn't that neat? All right, I'm going to let that go away. It's not, because some people are getting a little scared by it, but it's okay. I just wanted you to